You notice, like, so I've lumped these questions together because this is another rate of change one. Okay, I call these rate of change questions. No one else calls them that, I don't think. But because they give you a rate of change and they ask about like the amount or the derivative or whatever. Okay, so this is the rate of change, and we've seen several of these at this point. Not of cars through an intersection, but the cars turning left. All right. So if you plug a number into L of t, you don't get how many cars are turning. You don't get how many cars have turned left. You get the rate that they're turning left at that moment in time. Which means if I integrate L of t, what do I get? The number of cars that have turned left over that time interval. Okay? And that's the very first thing they ask. To the nearest whole number, how many cars turned left from 0 to 18 hours? Well, and they even give us a graph for this, which is nice. They don't have to. You can graph this on your calculator. But all we want to do for A is integrate from 0 to 18, L of t. Is that okay? And again, on my calculator, I'm going to go into y1. I'm going to type in what this stupid thing is here. Okay? So it's kind of annoying, but it's 60 square root of x. They like to give these square root trig functions like this because you can't integrate them by hand. You have to use a calculator to do these. Okay? And the way you put in sine squared, just so we're all together here, is you do sine like normal, but you don't have to put the squared right at the sign. You actually can't. And then you put in x over 3, and if you close the parenthesis and square that, although it looks like it's just on the parenthesis, it's actually on the whole sign. Cool? And if you're ever unsure about whether or not that's going to work, you can always put parentheses around sine the whole way. Like, this is a little overkill, but it'll work. So you can put parentheses around sine like this. Second, boom. Cool. See how I have parentheses around a whole sign now? So now it's squaring the whole thing. But you don't need to do that, but it's the same thing. Okay? So, now we got L of t in there, and all I want to do is this integral. So it's, again, math 9. I want to integrate y1 with respect to x from 0 to 18. And the calculator does all the work for me. And they say in this one to the nearest whole number, so make sure you're paying attention to that, and you get 1,658. And what are the units on there?
Cars.
In cars, because L of t was in cars per hour, right? So I forget what it was, 1,658? And that's all you need to show for A. Cool? That's probably 2 points. 1 point for the integral, 1 point for the answer. B says, they consider turn restrictions when L of t is greater than 150 cars per hour. Find all values where this happens and compute the average value. So that's a super complicated sentence, but hopefully you can get out of that. At least they're asking you to find the average value on some interval. Okay? And they give you this graph here. We want to know where L of t is greater than 150. So double check and make sure you're actually working with L of t at this case, and we are. That's a graph of L of t. Because sometimes they'll ask like L prime of t, or they'll ask for the integral of L of t to be over something. Okay? Then you got to do whatever operation you need to get to that function. But you can see the graph here. You see 150s right here, right? How many times does it hit 150? 2 times over there. And the times that it's over 150 are right here, okay? Well, just in between them. So all we got to do is find out when does it hit 150 and find the average value between those things. Okay? But we got to find those numbers first. So what I'm going to do is go to my calculator and I'm going to find out where that happens. Okay? So we already put this in as y1. You can graph 150 here. You could also do minus 150 on y1 and see where it hits 0. But I'm going to graph 150. So my graph's going to look just like this graph right here. So I'm going to graph it on the same window. So I'm going to change my window to go, x is going to go from 0 to 18. And I'm going to count by 2's maybe. And my y is going to go from 0 all the way up to 300. And I'm going to count by 50's. That's what the graph's doing. So when I graph this, I should see exactly what that thing looks like. How nice is that? And then we're going to see the line 150 come across. Boom. It looks just like the picture we got right there. All I got to do is find those two numbers. So now we want to find out where they intersect each other. Okay, so the way you do that is you hit second, calc, intersect is 5. And this one doesn't ask for an interval. You don't say like where to look. You tell it what two curves to find. Now we only have two curves here. We have the L of t and we have the 150. So you hit enter. And the calculator automatically switches to the 150 after you hit enter. Now it says what's the second curve you want to find. So hit enter again. And now there's two of them. So if you want to find both, you got to guess in the general area where they are. So it looks like that first one is somewhere around like 12, right? So I'm going to guess 12, and it's going to find the one that's right there. 12.42831. Okay? Now again, we need that number. We're going to have to use this number to get our answer. So we need this number out like 5 or 6 places. So I'm not going to round this. Right away, I know I need this number. I'm going to go to the home screen, and I'm going to store it as A. Okay? So I'm going to quit out of here. I'm going to hit store, alpha A, and it stores that number. On my paper, I'm going to write what I just did. I just found out where does L of t equal 150. And I got when t is, I called the first one A, and I'm going to write out what it is. 12.4283. Something. 0953. And I know it seems like overkill to write that out, but if you do it right, you only got to write it one time. B is this big number, stored in your calculator, you're good to go. Okay? And then we're going to find the other one. It also happens when T, I'm going to call the second one B. And I'm going to go back to graph, second trace, I want the intersection, that's 5. First curve, second curve, and now I want to guess where the other one is, and that's about what? Like 16? And you can see on the calculator, it puts like the X where you found it. So just make sure you find that second one. Well, you know because you get the same number again. But 16.121657, I'm going to store that as B in my calculator real quick. So second quit, store alpha B. And then I'm going to write it out. 16.1216. 5686. And really, look, if you got 3 places or 6 places, you're going to be far enough out. Okay, but if they give you more, just use them all. Okay. So once we know what A and B are, we're just going to find the average value. If my computer will cooperate. So it's 1 over. You don't have to write these numbers out. Just write the letters you used. B minus A times the integral from A to B. L of t dt. That's our average value formula. I'm just going to do that on my calculator real quick. So I'm going to do 1 divided by parenthesis alpha b minus alpha a. So that's the first. Make sure you put the bottom in parentheses. That's a big mistake kids make a lot. And then you want to do math 9. I want to integrate y1 with respect to x from alpha a to what have I done? Alpha b. And you get 199.426. Does this say to the nearest whole one too? Or just says what's the average value? Okay, so it's 199.426. Okay, and that's units are the same as, so if you find the average value of L of t, the units are the same as L of t. So this is going to be in cars, is it hour or minutes? Hour. Is that okay? Alright. And then C is a little bit weird, but they're really not asking you to do anything that we haven't done before. Okay? Their question says, ready? They're going to install a left turn lane or so, right? A signal. Okay, they'll put a signal in there. If at any given interval of 2 hours, all right, the product of the total number of cars turning left and the total number of oncoming cars. So what's product mean? This sounds really complicated. But what's product? Multiply. So if we can multiply the number of cars, the total number of cars turning left, how are we going to find the total number of cars that have turned left? We can make up an AT function, but really, if we have the rate they're turning left, how do I find the number that have turned left? Yeah, so we're going to do the integral of L of t. Does that make sense? Okay. Well, we have it from A to B. That's true, right? But A to B wasn't necessarily a 2-hour time interval, and they said specifically over a 2-hour time interval. A to B was a 4-hour time interval, it looks like, right? Does that make sense? Okay, so we can't use that Although the average number of cars turned left was 199 something, right? Okay, and 200 is our magic number here, by the way, because we're going to do 200 times 500. But anyway, we're talking about a product. We're going to multiply the number of cars that turn left, which is the integral of L of t, by the number of cars that are going straight. And luckily for us, the number of cars that are going straight is just 500 every 2 hours. Does that make sense? So all we're going to do is take 500 and multiply it by the integral of L of t over some 2-hour time interval. Okay? Now, if we're worried that too many cars are turning left, and you're looking at this graph, where does it make sense for us to check if too many cars are turning left? About what time?
14.
Around 14 or 15. That make sense? Now we need a 2-hour time interval around about 14. We should go from where to where? 13 to 15. Does that make sense? And look, I promise you, they're not going to make this question a no. Like, you're not going to have to guess and check all these different intervals. They're going to make it like fairly obvious. So as long as you pick a 2-hour time interval around that highest point, this is going to work out. Okay? So all we need to do is take the product of the cars going straight, which was 500, and multiply it by the number of cars turning left, which is the integral of L of t dt. Again, the tricky part of this is deciphering what they're telling you, first off, but now finding that 2-hour time interval. But it makes sense for us to go from 13 to 15. Okay? Or it really looks like that it's around 13 or 14.5, right? It looks like it's around 14. So maybe 13.5 to 15.5. Cool. Try to pick the interval that surrounds that maximum the best. So I might go from 13.5 to 15.5. That's a 2-hour time interval. I'm just going to see if this is greater than, what was our magic number? 200,000. If this is greater than 200,000, we need a signal. Okay, and you don't need to work it out by hand. We're going to do 500 times math 9. We're going to integrate. So you see the benefit of typing in this function, so you have to keep typing it over and over again. You have to integrate or derive it a bunch of times in every question. Okay, and we want to do respect to x, comma, 13.5, comma, 15.5. Kaboom. And we get 216,870. Okay? Which means, what do we need? We need a traffic signal. Yep. Okay? So we got 216,870. I'm just going to write, because they're not asking for that exact number, I mean, you can write the whole thing out. I'm just going to say that it's approximately 216, I forget already, 870 cars. Actually, not cars, like cars squared here. Really, it's cars times cars. Cool. So let's just take this number. And we want to compare that to the fact, get out here, that it's actually greater than 200,000, right? So then, always, if they ask you a question, answer with a sentence if it's like a yes or no question here. Does the intersection require a traffic light? Well, it says explain your reasoning. We just did that. We just explained what we're doing. We did 500 times the number of cars turning left. It was greater than 200,000. Cool. So we're just going to write like a little sentence explaining that. So, yes, this intersection needs a traffic signal since the product of 500 and the integral, this is probably even too much, of L of t 13.5 hours to 15.5 hours is greater than 200,000.